Hello, dear learners. Today's video is based on Introduction to UML. UML stands for Unified Modeling Language. UML actually is a subject as software design with UML in the fifth semester of Computer Science and Business System branch, but the object-oriented programming subject in the third semester also covers fundamentals and basics of UML. So today's video is based on the basic fundamentals about Unified Modeling Language. So let us begin. Before diving deeper into the subject, let me first give you a general idea, a generic idea. Here on the left hand side, you are seeing a layout of a building. This is something that is provided to us by an architect or a civil engineer or the constructor builder, but this layout is not very easy to understand. What is more easier is this complete visualization or the 3D visualization of any building or in fact of any artifact is easy to understand, is easy to perceive. Similarly, if we talk about the softwares and the software applications, and if we are provided with a code, then a code will be very tough for a layman to understand any software application. What any general person can better perceive and understand is something visuals. The pictorial or the graphic or the UI part of any software application is far easy to understand. So the UML plays a role here. UML is something which comes before coding and also comes before designing this UI part. UML will be a fundamental tool to understand and to get a clear idea about different looks and different aspect of a software application. So, summarizing this, we can conclude that UML is a general purpose modeling language. Okay, unified modeling language is a generic language which we use to visualize the way a system can be designed. It is working for a software application and we use UML to develop the blueprints. And these blueprints are similar to that of other field of engineering. Just like we use AutoCAD software to develop the models and the designs, 3D designs for machines, for automators, and for constructing any building artifact. UML is not a programming language, it is rather a visual language, which means that we use UML as a pictorial tool to specify, visualize, construct, and document different artifacts or different elements of a software system. So, dear students, this is the basic summary and the basic introduction about Unified Modeling Language. So, let us dive deeper and understand what is the timeline of UML. Timeline means how did the UML evolve? UML was basically introduced in the year 1994 by a team of three software intellects, that is Grady Bush, Ivor Jacobson, and James Ramborg. These three collectively brought the fundamentals of UML under the rational software, that is IBM. And dear students, Bush and Ramborg have also contributed a very nice book that you can refer for details of UML, oriented methodology and designing of softwares with the UML is a book which is contributed by Grady Bush and James Ramborg. Further, there were developments added to the UML. The UML 1 was introduced in the year 1997 and later on it was adopted as a standard by OMG, which stands for Object Management Group. It is a controlling body or authority which governs the different aspects of UML. Then UML 2 was born in the year 2003, and later on with further additions and revisions the UML version 2.5.1 was introduced in the year 2017. And dear students, this is the version that we are still using in the software industry for developing software applications. So this was the timeline of UML. Now we will see the UML conceptual model. It is very important to understand that the UML is based on object-oriented paradigm. Okay? As in the introduction, I said that UML is studied under the third semester in the part of object-oriented programming subject. This is because the UML has its heart lying around the object-oriented methodology. So the basic concepts of object-oriented programming are always followed by UML. Object, as we all know, is a real-time entity, and it is also a fundamental block of UML. Class, which is the collection of similar kind of objects, is a blueprint for objects, and a class holds variables and methods. Abstraction is the concept of hiding the background details and only showing the relevant one. Inheritance stands for deriving new classes from existing one, and it is a concept of reusability. Polymorphism means objects can exist in multiple forms for the different purposes under one common name. And encapsulation means wrapping of the data and objects into the single unit so that we can tightly couple them. And dear students, these concepts of object-oriented programming are also the basic building block of unified modeling language. So whenever we study UML, we have to understand that we are transitioning from object-oriented analysis towards the object-oriented design, which means that object-oriented analysis refers to identifying the object for designing a system. And the object-oriented design means emphasizing the requirements of a software system. This means we can combine the different objects together to achieve the intended associations. Associations, aggregation, composition are all the different relationships which exist in a class. So we can summarize the purpose of object-oriented analysis and design as to identify the objects of a system, to identify the relationships. These relationships can be association, aggregation, realization, generalization, specialization, and composition. And to make a design which is executable when the concepts of object-oriented are employed. So these fundamentals are very important to understand before diving deeper into the UML. We can summarize this part for developing a software as object-oriented software development, that we begin from object-oriented analysis, then we move on to object-oriented design, then we apply the concepts of object-oriented programming languages to build object-oriented softwares, which is called as object-oriented software engineering. And whenever there is again a new requirement, then these cycles proceed as follows. So this is a cyclic process. Now we will see the different types of UML diagram. But as I said in the introduction, we are not going to dive very deeper in this video. Each part type of diagram I will be bringing you in a separate video in the coming series. So the UML is categorized into two categories, structure diagram and behavior diagram. Sorry for the left-right part. Actually, the first one is structure. So we will be seeing this right-hand side part of the diagram taxonomy. The structure diagrams are classified further into 7 categories, as you can see here. And the behavior diagrams are broadly classified into 4 categories, which further classifies into the different 4 diagrams later on. So this is the taxonomy of unified modeling language, which is of 2 types, which creates diagram as a structure diagrams and behavior diagrams. And you can see on the screen the different types of diagram that exist. So moving on, first of all, let us clearly understand what is structure UML diagram and what is behavioral UML diagram. Structural UML diagrams show the visual representations of the static aspect of the system. Static aspects here refers to classes, objects, components, and their relationships. This relationship is association, aggregation, composition, etc. So this is the part which never changes. This part remains static all the time during the software development process. And the structure diagram gives us a very clear view of the system architecture. As it is not going to change, it is going to remain static and intact all the time. So this is a stable representation, a more solid and more consolidated structure of a software system. Now coming to the behavior diagrams, these refers to the dynamic aspect of a system. Dynamic means which will keep on changing. These aspects will change when the objects interact with each other and whenever the objects give response to the users. Whenever there is an event and there is a changes and then there is change in the software application, for that part we develop behavior diagrams, which means these diagrams show the response state of the software system. So I assume this is better that we wrap up the session here and I bring to you the detailed videos on each one of the diagram here in the series that we will be producing later on. So dear learners, I end up the introductory session of the UML here only, and in the coming series we will see each and every diagram deeply. Thank you for watching and this will be continued further with every diagram. Bye. Have a great day.